Hi, everybody. So as Agata said, my name is Kaylee Nelson. My background is in the astronomy department at Yale. As Agata said, I got my PhD there in 2015 doing what we call computational cosmology, which means that we ran universe simulations to try and understand how the universe formed. But I've been in this role ever since then. And what we do at the YCRC on the research support team, which is the team I work on, is we are here for you all to make sure that your research computing needs for your work are met. One of the major things that we do is support use of our high performance computing clusters, but that's not the only thing we do. If you have research computing needs that aren't specific to HPC, you can also reach out around that stuff. And that's a lot of what this workshop is also for too. I saw in the poll that about half of you have HPC accounts and half of you don't. And that's perfectly fine. Nothing I will be talking about today is specific to the HPC in general or Yale's HPC more specifically. You can use everything we're talking about just on your laptop or lab machines or wherever you're working on your code. But it is also a very useful tool to developing code for working on one of the clusters. So either way, in the chat, I've posted a link to download a little zip file. You can follow along. This is sort of a hands-on tutorial. I'll be sharing my screen in just a moment. You'll see that I have both the slides and a terminal open because I'll be typing in commands. So you can really see how Git works as opposed to just seeing slides of commands that without any context. So if you are in a computer that has Git, like Mac has it already baked in, you're welcome to download that zip, just unzip it wherever you want. And in a terminal, go to that directory and I'll tell you what to do from there. If you just want to watch, that's totally fine too. You don't have to follow along. It's not a requirement. As Agata said, if you have any questions that are like sort of broader high level questions about version control, if they could wait till the end, we'll do a Q&A then. But if anything is not clear, if I'm saying anything and you're not it's not clear what I said, and I could give a little more explanation, definitely throw up a hand or put something in the chat because with any workshop, we build on it as we go along, and I want to make sure that everybody's with us. So feel free to pop any questions up. And with that, I will share my screen. So welcome. I think we had somebody just join us. But this is version control with Git, and I am Kaylee Nelson. And the link here is just to the slides. Maybe Agata can post the link or something into the chat if anybody wants to follow along with slides. Otherwise, they're on our website. They can be distributed afterwards. So just a quick overview of what we'll be talking about today. I'll start off with just what is version control and what is Git more specifically, and then we'll get into the nuts and bolts of how do you put your code into Git. How do you connect your repository to GitHub so you have an offline copy of your code and you can distribute it? And then we'll talk about how you actually use the version control portion of Git. So not just saving your code, but also how do you utilize that history? Then we'll talk a little bit about how to use it for collaboration and some of the pitfalls or perhaps some of the complications that come along with that and how you should deal with them. And then we have a tiny bit at the end about the notion of branches and how you might work those into a slightly more advanced workflow. Let me get my, yes, there's only two little files in there. This is a very simple toy code for anybody who's opening the zip. It's just my figure here. I have the same thing open here. So it's just a little PNG and a little very simple Python script. So why would you want to use version control? I love this PhD comic. And I'm sure everybody has experienced this when they're working on a document where you're like, I'm done. This is the final copy. And then you do a revision and then, you make a copy of it and then you make a copy of the copy. And then like, this is the one with the bug fix of your code and all this stuff. And at the end, it's completely unclear which one was the one that was actually the one at the end. And if you needed to go back, which one was the one that had the thing in it. Version control wipes all of this away. And so you have just one thing that contains whatever versions of the past that you need. I love this quote from Bitbucket. I don't even know if it's on their website anymore, but I've put it here for posterity because I think it's a great illustration of why you would want to use version control. They say the whole idea behind any version control system is to have store safe copies of a project so you never have to worry about irreparably breaking your code base. One way that you can think about using version control is like a general coding safety net. So it's like you can feel free to experiment, add new features, rework the code, completely rewrite sections without ever having to worry that you're gonna want to roll those back and it's going to be a lot of work to do so, or perhaps impossible to get back to where you were. Version control makes all of that a completely safe adventure to go on. It's also just, of course, an easy and very powerful way to track the changes in your work. And a lot of people know that it's really useful for coding, but actually if you write in either like LaTeX or Markdown, you can also track your changes to that. Like I actually wrote all of my papers and theses in my PhD using LaTeX, using Git in order to manage and collaborate with my co-authors. If you set it up with GitHub, you also can get it so that's a backup of your work. So if anything happens to your local machine, all of your code is, and the full history of your code is safely stored in the cloud. I'm just gonna put this chat box somewhere where I can see it. There we go. So what is Git more specifically? So Git is one of a number of packages or pieces of software that do version control. There's some historical ones that you may have heard of, like Subversion. There's some other ones that came along and were sort of a flash in the pan, like Mercurial. But Git has been around for a while, and it is by far and away the front runner of version control systems to use. And that's because it's very powerful, but also fairly straightforward to use. So the way that it actually works is Git tracks changes to a file or a set of files through a series of snapshots, which in Git parlance we call commits or revisions. And you'll hear me use those words interchangeably. And then those snapshots are then stored in a repository, which contains a history of all of the changes to the file. So all of the commits and all of the revisions, all of those snapshots are stored in the repository. And we'll talk about the actual commands to make all of that work in a minute. So why would you want to use Git? As I already showed in the PhD comic, the clear file system, clear directory structure is one major great way to get to use version control. You don't wind up with code v2, this is the test version of the code, those types of directories. You don't have to monkey with any of that. You can just use one directory, your code's in there, and then you can use version control and branches to get around any times you want to make different or temporary versions. One of the things that's also really nice for particularly scientific work is you can check for bugs and inconsistent results. So if you're working on your code, you're generating a plot or a number, and then you make some code changes and all of a sudden that number's wrong or the plot doesn't look the same, and you're like, I didn't even think I touched that part of the code. You can use version control to just roll back to the last time that you knew that it was right, and you can see whether or not, like, where the bug may have been introduced, or maybe it was not even in the code. Maybe like something happened to the input data, and it can help you narrow down and troubleshoot that process much more quickly. You also, whenever you add something new to your repository, a new commit or snapshot, you actually write a little message to go along with it. So as long as you write a thoughtful message, you can actually have a record of your thought process as you made those edits, which can be a nice sort of like log to go along with your code development process. Just sort of in general, if you've ever written code and made a change and then all of a sudden it breaks, and you're just sort of like, why isn't this working? This was working yesterday. Version control allows you to just roll back to yesterday and then help you narrow down where the problem was. And just in general, it's an unlimited and extremely powerful undo button for code. And then lastly, one thing that it's very famous for is you can also do very good collaboration with it. So multiple people working on the same code base in a reasonable way. So how do you put your code into Git. So you have files in a directory like we have over here in my Git tutorial directory. And what you do is you create a repository, and we'll show the commands for that again in a second. But what you do is you add the files or the changed file to what's called the staging area. And that's where you basically build your snapshot. So you don't necessarily take a snapshot of every file in your entire code base every single time, because maybe not everything's changed, or maybe some things are still a work in progress and some things are a point at which you want to save them. And then once you've put everything together into that staging area, then you commit it to the repo. So it's sort of this two-step process. But before we get into the nuts and bolts, anybody who is following along on their computer, if you've never used Git before, you might want to run these two commands quickly, just because it's probably going to ask you as soon as you do your first Git add or Git init. Every time anybody makes a commit to a repo, particularly if you push it up to GitHub, every commit is tagged with the name of the person who made the commit and actually their email address, which is really wonderful because there's like contact info and sort of accountability or sort of a way to trace back who made what changes. So then if there's any confusion, you can ask them about it. So give you guys a second to just put these commands into your terminal. It doesn't matter what directory you're in, you can just do them anywhere. This will update a little file in your profile with this. You only have to do it one time.
I have a question.
Yep.
If you think you've done it previously, but you're not really sure, how do you check it?
Oh, don't worry about it. It will basically, if you think you've done it before and you haven't, when you go to do like a Git command in a minute, it will just ask you to do it then.
Okay,
and you can just do it then, or you can ignore it. But it just didn't want, sometimes people get tripped up by this like big warning message, which is basically just telling you to set a setting somewhere.
Okay, awesome.
Yep, no problem. All right, so those of you who are following along in your terminal, CD to the place where you unzipped the tutorial, the Git tutorial zip file. For those who are joined in a little late, a little bit later, let me repost that link. So if you click on that, that should let you download a Git _tutorial.zip file. Just unzip it somewhere and CD into it. And so what you want to do is just type git init. And so what this does is right now we're in a directory that literally just has a little Python file. We can look at it. It's just a little teeny sine wave. And then that makes, when you run it, it generates this little PNG that is literally just a sine wave on a graph. So what we need to do is we actually need to put the Git repository into this directory. And so the way you do that is you type git init. You hit enter, and all it says is initializing empty Git repository, and then this is the directory where I am currently located. So if you do an ls-la, which will show you hidden files, you'll see there is now a directory called .git. I'm not going to go in there. It's a place that you basically should never have to go monkey around in, but that's your entire repository. That is your version control history. All of the configurations are in there and all of the various different version controls. I can go back to the Git config thing here. Here I can, you can let me copy this. Oops, no, don't do that. Why don't I post the slides in, and that way anybody who's a little bit behind can copy the commands they need from the slides. Here's the tiny URL to the slides. That way anybody who needs to copy and paste something from the past can do that. But the most important thing that you should know about this .git directory is if you delete it, you'll be deleting your repository. So unless you know what you're doing, don't monkey around with deleting it or deleting parts of it or anything like that, because it could break your repository. And until we have it connected to GitHub, this is the only place that it lives. And so that could be a potentially scary process. That said, if for some reason you ran git init in the wrong directory, like perhaps maybe you were one directory up, you weren't quite in the right place, you can do an rm-rf of that .git, and then that will delete the whole Git repository, and you can move to the right place and rerun the git init. So that's the whole ball game is in that one directory. All right, so how do we actually add something to the repository? So every git command is prefixed with git and then something, and then maybe something else. So git add, and you do the myplot.py. And we're only going to add that file, and we'll talk about why in just a second. But for the moment, just do git add myplot.py. And so that just says git, this file is something I want you to track. That's like the technical Git term. I want you to track this file. Basically, be aware of it. And so if you ever are not sure where you are in sort of adding and committing and changes and all this stuff, a great way to sort of level set yourself is to just run a command called Git Status. And so this will print out a whole bunch of information about the state of the directory and your repository relative to that directory. So it tells you what branch it's on. We're on branch master, which I need to change all these slides to more inclusive language and change that to main. But at the moment, I don't want my stuff to be consistent with my slides. So on branch master, which is the traditional term, better or worse, for the main branch. It says that we don't have any commits yet. That's fine. This is a brand new baby Git repository. There's nothing in it. We've run git add my plot, so it says this change is ready to commit. So this section describes that staging area that I had talked about. And then there's untracked files, the .png, and we're just going to leave that as is. That's exactly how we want that to look. And then the second step is always the commit. So git commit, if you just run git commit, this will pop you into some text editor inside your terminal where you can write a commit message. But if you want to just write one in line, which I like to 99% of the time, you can just do -m, which is for message, and then you can write your message in quotes right after that. Basically, whenever you do an initial commit of your message of your repository, people just write initial commit. You know, it's like whatever state the code is in at that point in time, this is just like its first save. And so, you know, there's some details in here, but you don't have to worry about them. Like this is the commit hash, one file changed, blah, blah, blah. But no need to worry about that too much. All right. So as I said, oh, let me run git status one more time, just so you can see how it changed. So now it's no longer saying there's anything to be committed because we committed it, but it's still complaining about this untracked file. And so what are we going to do about that? So there are files that you don't want to save to your repository. There's actually very good reasons for this. As I had mentioned before when we were talking about how Git actually works, it looks at changes in a file. It doesn't look at the entire file. It looks for, you know, individual line changes, and it records information and reports information about those individual line changes. And obviously that works best if you're talking about text, you know, plain text file where you have line breaks in between your commands and whatnot. But a PNG, if you've ever tried to look at it, a text editor, is just like this you know, it's a binary file. So it's just like this crazy block of like nonsense character interpretations of the binary. If anything changes about it, Git has to recapture all of that information and put it in there, which is very hard on your repository. But more importantly is we don't need to save this, because if we ever need it again, we just run the Python script. So the rule of thumb that I always use in trying to decide whether or not you should exclude files from your repository is whether or not they are a product of your code. So if your code generates a plot, you don't need to save the plot. If your code is like C code and is compilable, you don't need to save the compiled executable. You actually probably shouldn't, because it needs to be recompiled on different machines. It can't, executables are not really transferable anyway. You know, PDFs generated by LaTeX, .pyc files, which are sort of the compiled versions of Python. Also, if you're on a Mac, they don't do this as much, but every once in a while you'll get those .ds_store files, like those will just junk up your repo, and you can safely leave those out of your repo as well. So anything that's a product or anything that doesn't really belong there because it just doesn't belong there, you should exclude. But it's pretty obnoxious to see this here every time I run Git Status and be like, yeah, I know I didn't want to put that in there. You can write a little file, and I do this for all of my Git repos, called a .gitignore file. And it's literally just a list of files or file types that you are saying to your Git repository, yes, I know this is in there. No, I don't want you to track it. We can just stop talking about it now. And so you can use your text, if you guys are comfortable with like Nano or Vim or Emacs, use your terminal text editor of choice. I'm a Vim person for historical reasons we don't have to go into. And you just create a new file called .gitignore, sort of all one word. And you can list things in here. So you can list specific files. So I'm on a Mac, so I'm going to use the .ds store. But then you can also use wildcards. So you can say, I don't want any PNGs, and this is a Python code, and who knows if it's going to someday get, more expansive. So I'll put star.pyc in there just in case. But if you were writing C code, you'd want to do like .star.o, the O files, the name of your executable. And you can expand and change this as much as you need to. You can also sort of preemptively put things in that you think might come up. It just doesn't, you don't want it to be a million lines long, but you also can, you don't have to worry about it being too heavy. So I'm going to save it. And then it doesn't do anything until it's part of the repo. So you have to do a git add. So we do another git add, add.gitignore, and then we'll write a commit message to go along with it. And that will actually shove it into the repo from the staging area. And we can just say added.gitignore. And now if I do a git status, it just says there's nothing to commit. The working tree is clean. So it's, look, it sees the PNG files there, and then it's like, oh yeah, I know I'm not supposed to track that. It skips right over it and just says that, every change that has been made and is supposed to be tracked in this directory is in the repo now. So it's in a clean state. Any questions about that? Cool. All right, so now we're actually going to change the file because that is right there in the description. So we're gonna make a quick change to the myplot.py. You can make whatever change you want. I'm just gonna add, let's see, we'll just decrease the amplitude. And so I've now made a change. And if I run git status again, it says that there are changes that are not staged for commit. And it tells you basically what file has been modified. Right now we only have one Python script in this whole directory. We know we changed it. This is, perhaps seems like overkill. But if you're in a directory with like 100 files or, even like, 10 files, running a git status and seeing which files have been changed can be really useful, because then you can just copy them right out of there. You can just do git add, copy the list of files that are modified, and then we write a little commit message to go along with it. Let's see, decreased amplitude. That's it. There, I increased the frequency. That's like 75% of your daily Git right there. Thanks all for coming. No, I'm just kidding. We'll get into all the other nuts and bolts and things you can do with this, but the takeaway is that these 2 additional commands are most of what you would need to get this into your daily workflow. Even if you never, you're sort of put on the back burner utilizing the history for anything, but you just want that safety net. All you need to do once you do the git init is, when you're working on your code, you occasionally do a git add and a git commit, and you'll be like most of the way there. So now we can get into a bit more of some of the extra features of Git. So how do you review changes? So let's make another change to my plot. Maybe we'll add an offset to it. So now I've got, we run Git Status. It will tell me that this file has been modified again. That's fine. But if you want to know what's actually changed in it, which is, again, often a good thing to do, maybe you worked on your code a bunch in the morning, you went to go get a cup of coffee, and then you came back and you were like, oh yeah, I should probably commit that change, but I don't remember like everything that I did. You want to review it and make sure that it's sort of the commit's been cleaned up before you put it in. You can run a command called Git Diff, and that will print out a really nice little summary of the file of the change that has occurred. So so here the minus sign in red, that's the old file, the old line, and then the plus sign in the green one is the new line. And if you had multiple changes, it has a way of sort of like breaking those out and give you that summary. One reason I really like to run this before I do a Git add, particularly if I've made a substantial code change, is you generally don't want to commit. Like one way I often debug my Python code is just putting in a lot of print lines where I'm like, print this out and then print this out and then print this out. And then when I'm actually done with it, I don't want all those in there because they'll junk up my logs. Some print statements are useful, but some are just for debugging and making sure that things along the way are correct. And so I can run git diff and make sure I've cleaned out the debug stuff and left in just the production stuff. And so that's one way this is really useful. But it also can be really nice to make sure that your message is a full description of what you want. So here we can see that I added an offset. Let's do a git add of my plot. And one of the sort of gotchas of git diff is a git diff of an unstaged change and a git diff of a staged change are different commands. So if you've already staged your commit, you've already run that git add, a git diff will return nothing. Like it literally returns nothing. Because it's only looking at unstaged things. So if you want to look at what's in your staging area, you have to do git diff -- staged. And then it's the same thing. So that way you can actually differentiate between changes that you've made and might think about adding to your commit and changes you've already added to your commit to make sure that it's what you want before you actually do the commit line, if that makes sense. So just so you know that there's these two versions of it, and depending on what state of adding your files you're in, you might want to use one or the other. So then we write a commit message, and here we added an offset, and that's now saved. So now to pull back just a second from the mechanics of Git to talk a bit sort of philosophically about commit messages. There's definitely an art to writing a good commit message. There's sort of a line you want to walk between not being too brief, but also like not being too like specific. The way I think of it is a commit message should be like a high level explanation of the change. So you don't want it to just be like changes. It's like, it's not particularly useful. There's a really good XKCD about it if you guys know that comic. But you also, one of the things you don't need to do is quote like exactly what the change was. Like, for example, here, if you say what line you changed and in what file, I mean, you could write that, but that information is already stored. Like that's something that if you run a git diff on the actual commit, which we'll look at in a minute, it's all in there. So it's sort of redundant. What you really want is like the human information of what happened. So like for me, it was like, I didn't say like added +2 to this line. I said I added an offset. And so, if you wanted to change a line from like a line in your plot from like green to red, you could say that. Or, if you want to describe the feature. Also, like my commit messages in this example are very short because we're making little tiny changes. But if you are writing a bigger feature, you can write a longer commit message. And that can be kind of cumbersome to do in line with the -m. So as I said before, you can just write git commit, and I don't have any changes, so it doesn't do anything, but it will kick you over into Vim or whatever your text editor, program text editor of choice is. And you can write paragraphs if you want. Like some people who, there's a mode where you combine your commits into one sort of more monolithic commit. So that's an entire thought, in which case you can write like a whole sort of description of the feature in the rework and whatever stuff that you did. So you can really use that log to whatever use it is to you, but I would just caution against like not saying anything, and like being too code specific and not sort of the human information, if that makes sense. The way you should really sort of like sit back and think about it is, if you were trying to read this message out of context 6 months from now, which like various different science experiments have shown is like, your memory 6 months ago is often like effectively a complete stranger. If you were reading something 6 months from now, would it make any sense, and would it be a useful message? So sort of, always be doing our future selves favors. So that's my little soapbox about commit messages. A couple other really useful commands you should be aware of, just because they will come up, is if you ever need to rename a file or move a file in the repository, like from one directory to another, inside your repository, you use Git MV. So those of you who are familiar with command line, MV is the command you use to either rename something or to move it from one place to another. You just throw Git in front of that. And same thing with deleting a file. RM is how you delete a file. Git RM is how you not only delete the file, but you tell Git not that file is being removed. Because if you just do an RM of a file, Git will still think it's supposed to be there, and it will say like, this file is missing. I'm not entirely sure what to do. Like, why has it evaporated? So you have to do a Git RM. And same thing with the move. It will just think the file is missing, and it will think there's a brand new file. So a Git move says, no, this file was over here and now it's over here. And that's reminding me that one thing I didn't make clear about sort of the scope of Git repositories is, so right now we're in a very simple directory that's just got these two files in it. The way you should think of the scope of a Git repository is any file or directory that is in the directory with the .git file here. I realize I'm like pointing at my screen, and that's useless to you guys. They got the .git file here, or a descendant of that directory. So if I made a directory here called, like app, and put things in there, anything that's in that directory, it's sort of the sort of Lion King. It's like, everything you can see is yours. And that's the way Git works. So anything that's in that directory, whether it's another directory, a whole directory, subtree, or files, that's in that domain of that .git directory. There are some very complicated ways to nest repositories. We're not going to get into that, and until you get there, I wouldn't worry about it. But that's one thing you should know, is your Git repositories, if you have multiple, which you should if you're working on multiple things, is they sort of need to be like neighbors to each other in some respect. They can't be inside directories of each other. I hope that's clear. Just throw a hand up or write in the comments if I'm losing anybody. So a few Git workflow tips. One is sort of about the granularity of projects and Git repositories. The way you should think of your Git repository and the messages is that it's sort of a story of this particular code base or project or whatever. And so if you've got multiple projects or multiple code bases that are like not super related, you don't really want to put them in one Git repository together. Like, you don't want one Git repository for like your entire research. If you have like 2 or 3 code bases that you're working on, or even 2 or 3 papers, like the way I worked in my PhD is I would have a Git repository per sort of paper project that I was working on. I actually would have two. I would have one for the LaTeX and one for generating all the data analysis and the plots. But that's only if you're using LaTeX. But you don't want to just throw everything in one, because if you think about it, if you're reading the commit messages back in, if you're sort of jumping between two disparate things all in the same line of commit messages, that is A, very confusing, and B, problematic if you wanted to roll back. Because say you wanted to roll back project A to like a month ago, but project B is doing just fine. If you have where it is at the sort of present version of it, if you had them mixed in one Git repo, they're not decoupled, so you can't change one without changing the other. So sort of think about that granularity. At the same time, you obviously don't want too many Git repositories. You want all of the code that you need for a particular project together in one place. So just sort of think of it, it's sort of at that, try to find that granularity for yourself. The other thing that I often get asked about is how often you should commit, what that cadence should be. So there are basically 2 points at which I generally write a commit message. One is after I've finished like a complete thought, like a change. Like maybe I'm trying to fix a bug, maybe I'm trying to introduce like a feature, and I've made like a substantial amount of progress towards that. I'll write a commit message there to sort of be like, saved. Okay, if I need to come back to here before I start the next piece of it, that would be a good sort of marker in the ground to have. But the other one is more of just like a save, which is before just like leaving for the day or leaving the work for the day. It's always nice to commit, as in the same way you would save a document before like getting up from your desk, just in case anything happened to your computer. But you can just, in the comment, if the code is in a non-working state, you can just write that in the commit. And that way, if you're ever trying to roll back the change, you'll know that state is expected to be, broken or unstable. So you can just say that, you can say like, working on feature, blah, 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 code is currently unstable or something, whatever makes sense, again, to you or any of your collaborators. But that's one way to do that. So I have a question here. For leaving work incomplete, is there a benefit to committing versus just adding the staging? The staging doesn't actually create like a marker in the mile. And if you were just locally on your computer, the staging adding step differentiating between committing isn't like the biggest difference. I mean, committing actually like saves a snapshot, where staging is just putting together that snapshot. So it's sort of in a halfway state. But as soon as we get to pushing, which is getting things up to GitHub, only a commit gets pushed. And so you will definitely want to do a commit and then do the push, because then you're like saving that back up to the cloud. And you want to do that as often as you reach some point you want to save, even if that's just leaving the work for the day, in case your computer blows up or something catastrophic happens, or less catastrophic things, you accidentally delete a file or whatnot. So that's everything I wanted to say about working in sort of an exclusively local environment. If there's no questions at this point, then we can get into connecting the repository up to GitHub. All right, so I'll talk about in a minute why we're going to use GitHub, but for now, just take it on faith. So how do you connect your repository to GitHub? First, you create a repository on your account. Those of you who don't have GitHub accounts, you can just read along, follow along. It will basically, once you've created the repository, it will tell you exactly what to do. So I don't need to type it here, but I'll show you what it tells me to do, and it will be slightly different for you. And then there's new commands that you'll need to put into your workflow, which is git push. All right, so how do we do this? These slides might actually be out of date because I think the GitHub interface has changed a little bit. So here I am, I'm logged into my GitHub account. And you can go to the plus sign here and hit new repository, or you can go over here where it says repositories and click that button. Either way, I will go here. You want to give it like a reasonably meaningful name. I am not going to do that right now. I'm just going to call this my latest work. And this name only has to be unique to you. It doesn't have to be like unique globally. So you just can't name it the same as exactly something else that you have already added to GitHub. You want this to, be the name of the code base, or maybe the, a short version of the name of the paper you're working on or whatever, but just something unique enough that you can find it. You can write a description if you want, you don't have to. And then there's this toggle here, whether or not you want it to be public or whether or not you want it to be private. Since Microsoft bought GitHub, they have graced us with unlimited private repos. So that didn't used to be true. It used to be you had to pay or get an educational account in order to get private repos, but that's not true anymore. I recommend most people start as private, and then I believe in open source and open science and all these things. I think it's incredibly important to share our knowledge accomplishments with the world. You can change this setting at any time. So you work on your code. I absolutely understand the need to embargo something that's not stable yet, or you're waiting to publish. But then maybe once you've published your paper, you can just go into the settings and toggle this to public. And that way you can cite it and other people can cite it and use your code and whatnot. And then there's all the stuff about licensing. If you go open source, I'm not a lawyer, so I'm not going to go into that. But there's some very good documentation on the internet that can help you make the right choice if you do want to open source your code. And we will just ignore these because we are in fact importing an existing repository. So private, whatever you want the name to be. And then you just hit create. Okay, so this is what I mean by it tells you exactly what to do. So you find, I have my Git set up to use SSH keys, so I don't have to type in my Git password. You guys probably do not, so it will ask you for your Git password when you do your perhaps your Git pull, your Git clone and your Git pushes. So just don't be alarmed if everything looks a little different from me than it does for you. If anybody has questions about how to set up SSH keys for that, so you don't have to type in your password, I'd be happy to talk about that. So anyway, so this would be creating a new repository from the command line. So this is if we hadn't started anything yet, but that's not the case. We have an existing repository, so we're going to use this set of commands. And again, yours will look different than mine, not only because my username is different from yours. So copy each of these lines into your terminal from your screen. User. Actually, I'm not sure what that's going to do because my branch is called master. So I think that's going to do something confusing. There we go. I think that's what I need. They have clearly changed to the more proper language for this. I need to update my local Git to match that. So these are all the slides that we've already seen. Oops, status. Just making sure that we're in a working environment, a working tree rather. I have already committed. So now, since we have a little bit of a repository already locally, what I'm going to do is do a git push, and that will push everything up to the cloud. Ta-da! So now it's up there on the cloud, and it looks like it did. Okay, this is confusing. Just ignore this main master thing. I'll get that straightened out for the slides. So now the thing to be aware of is anytime we make a change, we'll make another one. Oops, let me remove this app thing because that's just going to create confusion. We'll perhaps decide that oh, maybe we'll create that. See. Let's make this 4. Oh, that's what it was originally. We'll make it 5. Just want them to be distinct, otherwise things get uninteresting later. So I made a change. I will add it, and then I'll commit it. And then, so it used to be add these 2 lines to your workflow and your version controlling. Now it's add 3 lines to your workflow and your version controlling. And so then we do a git push, and then we reload the cloud. And you can actually click in on the file, and it will show the status of the file here. And you can see that it has, since I did git push, it sucked this up into the cloud. And it's got my most recent changes there. Any questions or anybody having trouble getting this connected? No? All right, excellent. So as promised, I'm going to talk for just a second about why I recommend GitHub. It's really wonderful that for everybody who signs up with a free GitHub account, you get unlimited, free public and private repos. The funding model for GitHub, they make a lot of their money off of enterprise or companies. The other thing that's limited is when you have a private repo, I think you're limited in the number of people that you can add as collaborators. And so, if you have a private repo and you want, I think it's like 5 or something, say you want to share it with 10 people, then that's when they're going to start asking you for money. If you make it public, you can have as many collaborators as you want because it's public. In a second, I'll talk. There is a way to get unlimited private repos that you can share with as many people as you want, because you guys are researchers. You're affiliated with an academic institution. You can sign up for an educational or researcher GitHub account. I think I may have the link to do that at the end of the slides. If not, I will add it before these slides get reposted. It's just a little form you fill out, and they give you a free, fully paid for account. They give you like the full pro account or whatever it's called for free because you are sort of an education researcher, which is really wonderful of them. Bitbucket also has the same thing: unlimited free repos, unlimited private repos for a limited number of collaborators. You're welcome to use it, but if you sign up, do not sign up with your yale.edu account. Sign up with like your Gmail or whatever your personal email account is. The reason for that is at one point Central ITS sucked in Atlassian, the sort of yale.edu Atlassian domain space. So if you sign up with your yale.edu account, it gets sucked into the central Yale account. And when you graduate or leave from your postdoc or ever want to leave Yale for whatever reason, you will lose access to your repos, which is not a great thing. You can go through the hassle of migrating them to another account or to GitHub, or you can just start in the right place to begin with. So that's the big asterisk on that is I strongly recommend you do not sign up for Bitbucket with your yale.edu. You can sign up with GitHub with your yale.edu, and you can actually put multiple email addresses in your GitHub account. So, if anything changes, it's relatively easy to swap that around without creating a new account. And then some of you may have heard about git.yale.edu, which is the Yale Enterprise locally hosted. I actually think they are moving it to the cloud, but whatever, private Yale GitHub installation. These are free, fully featured accounts, but they're only available in the Yale network, and you authenticate with your NetID and password. So again, one of these situations where if you ever leave Yale because you graduate or your postdoc ends or you leave for whatever reason, you will lose access to those repos. And perhaps even as importantly, you cannot share those repos with anybody who's not at Yale. So you can't share them with your collaborators at other institutions. So I generally just like wave people off of that. Central ITS uses it. It's works for them because these things need to stay at Yale. We use it for some of our stuff historically because that stuff is always going to be at Yale and only for Yale. But for research, it's just not for you guys. So I would just pass right over it. All right, so we've built this really beautiful history. How do we actually look at it? So one way you can look at it, and this is what actually I recommend as one of the more intuitive ways to peruse your history, is you can actually just do it on the web interface. You can click right here on the number of commits. There's a number of ways to get into this, but this is one of them. And this just prints all the commit messages of all the commits that I clicked on, excuse me, that I have added to my repo. So here's my initial commit. It tells you who did it, and it tells you when it happened. And then this over here is the commit hash. This will put the commit hash into your clipboard so you can paste it. There's shortened versions and long versions of the commit hash, and I couldn't explain to you the important differences, but they seem to be fairly interchangeable. And then you can click on the commit hash, and this will actually show you that a sort of a slightly more detailed version of that Git Diff that we looked at before. So this is the sort of before and after. So this is an initial commit. So there was nothing before, and then there was a file, which is perhaps not the most interesting one. So if we click on this one, it shows you instead of stacked. Thanks, Holly. Let me email me if you have any questions. It shows on the left the things that were removed, and it shows on the right. I'll take a look at that in a second, Jamie. What was changed over here, and then what was added over here, so you can see them. There's also there's lots of different ways you can. This looks exactly like it did in the terminal. There's a number of different ways that you can sort of look at this information, and you can read the commit message up here. And then if you're working with a collaborator, you can actually write comments on their commit. So you can be like, I don't understand, or maybe I think there's a typo here. You know, when you did 2, did you really mean 4? So you can actually communicate and collaborate actually within this interface here, which is kind of cool. The other thing that you can do just in the web interface, which I like quite a bit, is at this commit, you can click Browse Files. In this, it's not particularly interesting because we only have one file, but if you wanted to see what some of the other files look like at that same point in the past, you can click Browse Files, and then you can go and look at a different file and see what the state of that file actually was at that point in time, which is kind of cool. That's a great way to get like sort of a peek into the way a code looked in the past. But you can do some of this in the command line too. And just for completeness, I'll show you these commands. So at any time, if you want to see the detailed history of everything that was committed, the command is git log. And so this is information on the commit hash, which is the name for this crazy string, who did it, when it was done, and then the message. That's sort of the default output. And then there's like a bajillion flags for this to make it look exactly the way you want. So if you only care about the last one, you can do dash -1. And so that just shows you the last commit that was made, usually like the one you were on. You can do, if you want it sort of a more compressed view without all of this stuff, you can do one line. And so that gives you just like the minimal hash that you need for referring to it. And then just the command, just the commit message. It doesn't tell you who did it. You know, if you're working all by yourself, you know, this might be overkill. Okay, thanks, Jamie. So this can be a nice way to just quickly read through your messages of what happened. If you know the commit message of the hash that you're looking for, it's gonna be a great way to just like quickly find it. And I'll show you what you do with that hash in a second. And then there's lots of flags. Like there's ones that will show you the diffs inline. There's ones that you know, can help you look for things, etc. So if you're interested in playing around this with the command line as opposed to the web interface, I just recommend you read up on GitLog on the internet. It's perhaps too weedsy to get into in this particular workshop. But one of the cool things you can do in command line is like we showed on the web interface, is you can compare 2 commits to each other. So the most obvious one is where we are right now with some time in the past. So in Git parlance, your current location, not necessarily the present, but where you are in the timeline of your Git repo, is called the head. So that's your current locale, your reference frame, so to speak. So if I just want to compare it to where I am right now with some time in the past, so we'll grab, maybe this one. You can compare to that with the point back then. And one of the cool things that I really like about this is, we obviously made multiple changes between this commit that I just compared us to and the head where we are right now. But it doesn't print out every single change that I made. It prints out what's different between those two. So like if you added a change and then removed it, or changed it and then changed it again, it's not going to make you follow that train of that thinking, or that whole all those steps. It will just show you exactly what's different between the two, which I find very nice, that it collapses those things down. You can also compare two arbitrary revisions. So if you want to say like what was different between that one and the next one that came, you can do just 2 hashes instead of head. So as I said, I actually more often than not will actually just go to the interface, because then you can sort of get into, usually I have a follow-up question, and and in the web interface, it's a little bit easier to get into sort of more information about like what happened in those different, like what was the next thing that happened, or what other file was changed. And so the web interface makes that possible. And everything I'm showing in GitHub, if you do choose to go with Bitbucket, which I have nothing against, it's just a bit more complicated with the Gale setup. All of this, it's slightly different buttons, but all of this functionality is available over there. All right, so far we've just talked about adding things to the repository and looking and comparing things in the repository from sort of a passive mode. So now we're going to talk a bit about, sort of the time travel aspect of version control. What if you actually want to go back to a previous version in a, more than a just compare it to the present or a different point in time kind of way? This is called checking out. And you use those commit hashes to make a reference to whichever one you want to check out. And so the way you should think about this word checkout is more like check out something from the library than it is like check out as in like look at it. Because you're really, it's going to change the state of your working directory to be what it was at that point in time. It's not just going to like print something out for you. And that's something that can be a little jarring the first time you do it. I know it was for me. Because like if you go far enough back, like files might not be there that you have written, and massive changes that you made are now like reverted. But don't worry, all of that present tense is stored in the repo and you can go back at any time. But I just a big heads up on that. All right. So how do you do this? So let's do the git log -- one line again and get the list of the git hashes and the commit messages. And then I'm gonna pick one, sort of at random. Go back to here. So you do git checkout and then the hash. And then it's going to print out this sort of scary message that will say that you are in a detached head state. What that means is the time travel analogy is really sort of appropriate here. You can travel back to the past, but you can't rewrite your timeline. If you think of your Git repository, all of the commits as a timeline. So if you want to make change, if you want to go back into a previous revision and you want to start changing things, you have to create a branch in order to start saving those, because it can't save over the already written timeline. You have to create a branching timeline. We're in one of those, time travel paradigms where you have branching universes as opposed to, where you rewrite history kind of thing. So it says that if you make any changes and you want to save them, then you're going to have to create a branch. And it explains how to do all of this. But we're not going to get into how to do that today. We're just going to talk about how you step into the past and look at things, and then how do you return to the present state, because this is a bit more of an advanced maneuver. So if we do an ls, the state of the directory has actually changed. So if I look at this file, it doesn't have the frequency change, it doesn't have the offset that I added. The file has been completely reverted to that state. And again, if there were files that I had created in the meantime, and I git checkout back to the past, those files will be missing, or will appear to be missing. They will no longer be in the directory. Or if you rename something, it will be reverted to the previous name. The other thing to be be aware of is that if you check out an old revision and you have changes that aren't committed, like they aren't saved, if you then go back to the present, it doesn't go back to the state of your directory at the time you ran checkout. It goes back to your latest latest commit, your commit that is furthest along on the commit line on the branch. So if you have like a file that you didn't add, if you have any of these things, when you go back to the present, those changes could be lost. So that's just something to be aware of. It's sort of what you would expect, but it's something to just be aware of. So the way you get back to the present is you do git checkout. So before you did git checkout the revision name, and then if you want to get back to the present, you do git checkout and then the name of the branch that you're on. And then that will put you back at the top of your branch. So you'll see that we've got the frequency is 5 and the offset is 2 again. So that's sort of how you are like, okay, I'm done looking around the past in the purely observer mode. I want to go back to the present. So why would you perhaps want to go back into the past if you can't actually like change things and save stuff? One really useful one use case for this is if you have if you're working on your code and all of a sudden the data, like your plot is changed and you don't think that you broke that part of the code, you're worried maybe the data changed or something happened, you're trying to figure out what happened, you can go back to the last time that you knew that it was working by doing the git checkout, the revision of that state. And then you can just rerun it because it's a completely active directory. You can rerun your code at that point, see if it produces the output you expect it to produce. And if it doesn't, then the problem isn't the code, the problem is something else. And if it does produce the same output, then you can start digging into, what code actually changed, what perhaps had an effect that you weren't expecting. So that's one reason. The other thing you can do is you can pull back. Well, you can't go back into the past and change things and then start saving stuff without creating a new branch. What you can do is you can reach back into the past and you can pull a specific file forward. So if you want to, if there's a file that a few commits ago you started working on a, maybe like a rewrite of or a refactor of, and it just like went horribly awry. And you're just like, I want to just go back to that and start just like refresh, reset that. You can pull a particular file from the past forward without getting into that weird paradigm of branching timelines. And so the way you do that is you do a git checkout revision name, the same as before, but then you pass it also a file name. So in this case, we'll do myplot.py, and that will pull it from the past into the present. And so now that file is modified because all Git knows is that it was different from the way it was before. And so then we can commit that. And you can see it was already added to the staging area, but it tells you how to unstage it if for some reason you would like to do that. So we'll write a commit message, which was like, resetting file to commit, something like that. And then we can push it because you want to save that to cloud. And then we do a git status. And so that's if you want to revert an entire file, like one whole file to a previous revision or multiple files, that's the way I recommend doing it without getting into detach heads and branching and then merging those branches. That's sort of the lightweight workaround. You could also, if it's a particular chunk of code that changed, you can obviously just copy paste that from the way it was before, go to the present, paste it into the place where it needed to be reverted, and then do a regular Git add. So there's a few workarounds without getting into some of the more complicated maneuvers that can still let you use that past in updating your present. Any questions about that? Cool. So one other really useful command is I'm not actually, Jamie's asking about git diff with a ... in it. I've never seen that, but let's see what it does. Git diff head, and then I'm gonna need to pick a different. And then we can just go back here. How is that different from? Yeah, I'm not actually sure what the difference is between using the ... and not. Maybe it's because I'm using two commits that are really close to each other. Let's go further back. Yeah. So this is. Yeah, I'm not sure what the difference is between those two. Sorry, Jamie, for not being more. Not having the answer to that. So if you are working on, where are we? Okay. So if you're working on a bunch of code and you decide that you haven't saved anything, that you haven't committed anything, you just like decided that like that thought process or that thing that you were doing was sort of a mistake, and you just want to like undo it and go back to the previous save change. Like maybe you wandered away from your computer and you're like cat like stepped on your keyboard, or like you didn't realize you were in the which directory you're in and you like deleted a file, or any of these things. This is a useful command to just sort of have in your repertoire. It's git reset. So let me make a change. So what if I just like introduce like a whole bunch of like stray characters here, like maybe my cat walked across my keyboard here. And I'm like, I don't want to like go through and delete all those lines and whatever. I just want to like undo it. You can do git reset -- hard, and that just sends you back to the previous commit. And so that can be a nice way to just like throw away a bunch of work that you didn't or erroneous characters or whatever it is. Just reset yourself to the last save state. But of course, warning on this: any uncommitted changes, whether will be lost. That is kind of the point of the command, but I like to throw that warning in there too. So just it's a bit of a nuclear option, but it's nice to have sometimes. So that's sort of the entry-level version of how to use your actual version control history. So you can travel back in time, you can look around, you can decide if there's some code in there that you do want to bring forward. You can go back to the sort of present state, and you can either paste in whatever the fix was and make a commit, or you can check out a particular file from the past and bring it forward if you sort of more holistically want to revert something. And so what do you do if you want to get your code in another location? So say you've been working on your laptop, it's all here, it's in GitHub, that's been working really well for you. But maybe when you're one of the 50% of you who has an account on one of our clusters, and you want to get the code in the cluster, you could copy the file, copy your directory up to the cluster, or you can actually just copy, you can clone it, that's the word, you can clone it down from GitHub onto your cluster account. And that way you can use GitHub to manage changes between that, as opposed to trying to copy files in between the two. What I'm going to do is just put them next to each other here. That's also a completely legitimate way of doing it. For some reason you want to muck around in a parallel version of your repository, you could do that, as opposed to creating a branch. It's a little bit, eventually you'll wind up with some collisions. And so I wouldn't recommend that as an alternative to branching, but there's no reason why these things can't live next to each other. So that's what I'm going to do, as long as they have a different name. So the way you do that in the GitHub interface is you can just write git clone and then figure out what this is, or you can just click this code button, which will show you what the clone line is for yours. And you click this, so it'll copy it. Again, mine will look different because most of you are probably here. I'm on SSH because that's my SSH key. And you can click that button to copy it. And so now I'm one directory up. So just to be clear, I was in Git tutorial. That's where we've been working all along. And now I'm going to go up a directory, and then this will create a new directory called my latest work, because that's what it's called on GitHub. And so you type git clone, and then you paste in what you copy from this code dropdown. And it says cloning. And then, I got to go into it, of course. And you see my plot.py there. What you don't see is the .png file, because we never added that to the repository. It's not being tracked. And so if I want it again, I just run my plot.py and it will generate whatever the latest version of that PNG file is supposed to be. But the .git ignore is there, and the .git directory is there that contains the whole history, and the connection to GitHub is in that file. So there are now two copies of my code here. The original one in Git tutorial, and my latest clone over here in my latest work. So that's cloning. It's very straightforward. It just creates a new copy downloaded from GitHub. But the nice thing about it, as opposed to like downloading the zip and expanding the zipper or whatnot, is the copy of the repository it downloads has the actual repository information and the connection to GitHub. So I can go right ahead and start editing this file, do a git add, do a git commit, and do a git push, and it will all just like go back up to GitHub. I don't need to set it up. If you do a download of the zip, that will only download these files. It won't download the whole repository. So this is really great if you want to like send somebody your code who's not going to be editing it. So if you have like collaborator and they're like, oh, I'd love to run that thing that you've been working on, you can download the zip and send them the zip. If for some reason you don't want to give them access to your repository to clone it from there. So that's what the differences between those two are. It says the repository information. This is just literally the files in the current branch, or the current commit that you are on. This is also, if anything happens to your laptop and you want to restore your repositories, this is, the way to do that. Is you can just do a git clone onto your new computer. All right, so now let's chat a little bit about collaboration. And I see that it's already 2:50, but I've just got a few more slides, so I think we should be okay on time. So once your work is up in GitHub on this remote repository, it's then very easy to start collaborating with others. One of the main selling features, the reason it was written, is Git is the sophisticated system for managing multiple people all banging on the same thing at once in a way that like fluidly and most of the time automatically is able to make all the pieces fit together when everybody tries to save. If any of you have ever tried to save a Word document that somebody else is already editing, like in your Dropbox file or something, and you get a conflict and it's just like a nightmare. Git, it was written as a way to sort of get around some of that. And so some examples are obviously multiple collaborators on a code, but also, as I said before, if you're writing something and there's like LaTeX involved or like Markdown, it can be really useful for that. Like our docs site for the HPC, the user docs, if you've ever been to docs.ycrc.yale.edu, that is actually all written in Markdown, and that allows us to all sort of work on it simultaneously. Nowadays, it was before my time, which makes me feel old. Nowadays, if you're working on LaTeX collaboratively, you can use something like Overleaf. And if you have any questions about that, definitely email us because we have an institutional account. It's basically Google Docs for LaTeX, but it also has GitHub integration. So you win in both ends. So how do you share your repository? You go into settings here, and then you go to manage access. I'll update the slides. I'm realizing now that they have changed the settings menu yet again. You go to manage access, and then you hit add people. And then you just need their GitHub username, or sometimes you can look them up from their email address or their full name. But like we can look like, look up people here. This is my husband, so I could share it with him. He'd be very confused. But you can, if you have somebody's username, you just type it in here, and then you just click add, and then you can just click add them to this repository. And then you can control their level of access. So you can say they just can download it. They can just pull new changes in, but they can't write stuff, or you can say they can write stuff, or you can make them like a full like co-owner so that they can invite people too. You can change all of that stuff to whatever level of access you would like to give them once you've added them. Once you add them, click that button, the invite will be sent to them that they need to accept, and then they'll be able to see it. And then once they are in the code base, like in the added as a collaborator in GitHub, they will see this interface if they go to the same path, and then they can do a git clone onto their machine. And collaboration, I'm talking about another human being, but collaboration is also something that the collaboration workflow is something that is also important to be aware of if you have the same code in multiple places, even if you're the only one working on it. So if you have the code on your laptop and a lab machine, or you have the code on your laptop and the HPC, if you're working on it in both places, then that's collaboration, because you've got two working versions of the code, both writing to the same repository. And so even if you're never going to work with somebody else on your code, or you don't, envision that, this can still be useful for working on your code on multiple machines. So the basic workflow is, excuse me, there's now one more command. We're up to 4 now. Before you start working, you do a git pull, which is the opposite of a git push. And so that reaches out to GitHub and it says, hey, are there any commits I don't have? And if there are, it downloads them for you and integrates them into your local repository. And then you work on your code, make whatever edits you want. And then it's the same: git add your files, git commit your message, and then git push to send that up to the cloud. So what happens when inevitably 2 people, even if both of those people are you, have made changes to a file, or the repository or the code base in general, and neither of them have done a pull, or they do it at the same time, make the changes at the same time. Nobody's done a pull before they try to do their push. Then you get into what is called merging. And one of the beauties of Git is if those changes are on separate lines, like they don't even have to be in separate files. If they're in separate lines of one file, Git says, I know what to do with this because I have each line as a separate thought in my repository. I'll change line 10 from what that person said, and I'll change line 25 based on what that other person said, and beautifully automatically merges those things for you. It will create a new commit when you do a git pull, and it will say like, there's a merge here that I need to make, and it will pop up the little commit message interface in Vim or Emacs or Nano, and you can just type merge. That's what I normally do, or you can write something more expansive if you want, and then it creates a new commit that is the merging of those things, but it's fairly hands-off process for you. And so just like, don't be alarmed when it happens. It is mostly being taken care of under the hood. But if you both edit the same line, then that creates what's called a merge conflict. And this is like perhaps the most intimidating thing about basic Git, that most people like feel overwhelmed by, but I'm hoping I can explain it to you in such a way that you will feel capable of handling it. One story I like to tell is I had a collaborator when I was working on my papers who like was so intimidated by merge commits that if he ever ran into one, he would just create a clean clone of the repository from the web interface and then copy his changes in and then do a commit, just like overwriting whatever like the conflict was, which is an extremely brute force solution. You don't have to live like that. You can learn how to manage merge commits. But basically what happens is two people have, there are two versions of the code with changes that don't match on the same line. And Git says, I am a computer. I refuse to make this decision as to what this line should actually look like because I have two versions of the code telling me what it should be and they don't agree. So it then just says, I am now making this a human problem and you say what it should look like and then create a commit and we can all move on with our lives. So how do you resolve it? So what typically happens is you type git pull. Maybe you've already made a change locally that you've either committed or not. And you do a git pull in preparation for doing a git push. And it says auto merging. If that was successful, it will just kick you into that merge, that commit message interface, and you'll type a commit message. If it fails or there's a conflict, it will print out this. It will say merge conflict, automatic merge failed, fix conflicts, and then commit the result. And what that looks like is it will tell you what file the merge conflict's in. And so you just need to open that file in your text editor of choice, and then you will see a series of lines that look like this. Like you can actually just like do a find in the file for a whole bunch of sideways carrots. And it's a little opaque, but basically this is what you have locally, and this is what the commit that you're trying to pull down wants that same line to look like. And all you have to do to make the merge conflict go away is make this section of code whatever you want it to be. So basically everything between this sideways caret that points that way and the end of this commit hash, this needs to go away. And it needs to be replaced with nothing, whatever you want it to be, preferably some working code that makes sense. But the only thing Git's going to look for is whether or not these have gone. So maybe you think that your solution is correct, in which case you delete this line, this line, this line, and this line, this line. Maybe you think this is correct and you delete this and this. Maybe there's some joint solution and you delete them all and you write something new. Doesn't matter, whatever it's supposed to be, you write that, you delete this section, and then you just do a git add, git commit, description of your message, and then push, and you're good to go. That's it. There's no secret sauce. There's no needing to tell Git that the the conflict has been resolved. It's just looking to see that these lines are gone and replaced with like seemingly normal code. And that's it. The other thing that can happen that's a little scary is if you have been editing a file and you do a git pull and then you have an uncommitted conflict. So you haven't actually saved your changes into a commit yet that's conflicting with the commit that's being downloaded. Instead, you've edited a file and then you've done a git pull and it's worried it will overwrite your unsaved changes. And it will just throw a warning and say, you either need to commit these or remove them. And then you can redo the git pull. And so you can do one of two things. You can either commit those changes, and then you redo the pull, and then you probably wind up maybe back here, and then you do this. Or you can just say, I want whatever they have and forget what I wrote. And the way you do that is you do git checkout dash the file name like this. And what that will do is it just reset. It's sort of the equivalent of doing a git reset dash hard, except that applies to your entire directory, where this will just reset that one file. And so, which is like a little bit of a safer thing to do. So what this does is it just resets it to the state that it was at the last time you committed. And then because it matches the last commit, you do a git pull and you're good to go. So that's the way out of that particular pickle. And that's it. That's conflicts. That will, if you follow those things, you'll basically be able to resolve every conflict you bump into. I know we're running a little short on time, so I'll go through branches really quickly. This is more of just a philosophy on branches because I get questions about them than it is about the mechanics of using them. But basically, branches are independent timelines for your project. Master or main, as we now call it, is the main one. This is generally considered to be in a more public coding paradigm, the one that's more or less guaranteed to be stable. If you're working on your code by yourself, 99% of projects that I work on all by myself, I just have one main branch. And sometimes it's stable and sometimes it's not. But if you do want to get into a more structured mode, there's two ways to work on branches. Basically, you leave this as always stable, and then the unstable code goes onto a branch. And you can have as many branches as you want. You probably shouldn't have a million, but there isn't really a limit. So a common branching workflow is you have your main one, which is you're sort of expected to be stable. People can pull commit off of any point in that, and it's expected to like compile and run. And then you work on the new feature. You can either have one branch that always runs alongside your main branch. That's called, so somebody's asking back about the conflicts. What's the file that you edit to get rid of the head? Whatever file has the conflict in it. So whatever file has the conflicting change, and Git will tell you what file that is. And so you just look in the error-ish thing, the warning that Git throws, and it will tell you what file to look for. I hope that makes sense. So there's two paradigms. One is you just leave a development branch or develop branch, whatever you want it to call, always running alongside your main one. And that one is where you monk around and then you merge those changes in when they reach sort of a stable state. Or you can create a branch that's more temporary, specifically for the work that you're doing, either a new feature or a refactor or whatever. And then when you're done with it, you close that branch and then you open a new one for the next thing. So these are the mechanics of it. I'm not going to type these in just in the interest of time, but basically to create a new branch, you use that checkout command. So git checkout and then -b, which stands for branch, and then the name of the branch that you want. And then then you need to tell GitHub that branch exists. And so that's what that next command is, git push origin, and then again, the name of the branch. And that way the branch will show up here in this dropdown and you can toggle in between them. And then the way you switch branches is, again, that checkout command. So your main branch, you do git checkout master, main, or whatever you called it, or whatever your Git configuration called it. And then you can switch to the other branch by git checkout the name of the branch. And branches work kind of like going back and forth between revisions. If you ever switch branches and you have unsaved changes, you'll just lose them, because when you come back, it won't come back to your previous working state. It will come back to the latest commit on that branch. So it will come back to the last save state, not the last working state, if that makes sense. When you're ready for whether you're going to close the branch or not, when you're ready for those changes to be incorporated into your stable branch, your main branch, you do a merge. And that will incorporate those changes into, just like if you were doing a git pull, but instead usually has much more extensive set of changes. And generally there's ways to do it in command line, but generally I just recommend doing it in the web interface. And the way you do that is a pull request. And so it's up here. If you have two branches, you can click on one of the branches and do a pull request, and that sets up okay, here's everything that's coming from branch A into main, devel, or the feature branch into main. You review those changes and then you hit merge. And then there's a little checkbox at the bottom that says whether or not you want to close that branch. And so if you're doing a feature style workflow where you close the branches and create a new one for the next feature, you close it. If you're doing the development branch, parallel branch style, you can leave it open. And just continue working on that and then merge it in and leave it open. Hopefully that makes sense. I know you're going through this very quickly, but until you get into more heavy coding or more heavy collaboration and putting public code out, that's still being developed, if you're just working on something for yourself, I wouldn't monkey around with branches too much. I would just write thoughtful commit messages so that you can go back to where you need to, if you need to, and leave this for future exploration. All right, so that's everything I wanted to say. But basically, to summarize, if you just add these 3 commands to your workflow, you get all of the power of version control. You get the unlimited to do, you get the coding safety net, you get online backups of your code. If you just do git add of your files, git commit -m, and git push. I really like this. In case of fire, git commit, git push, leave building. That will get you most of what you need. And then, if you ever need to go back into that history, you can use the web interface to do it. If you are ever confused, that's what we're here for. And the way to reach us is research.computing.yale.edu. Just write a message in there, and that will find us. And there's some more information if you ever want to dig a little deeper. Try.github.io is a great tutorial on Git if you ever need a refresher. If this link is still live, and I'm sorry for not checking it before we get started, this is a nice little online sandbox where you can try out Git commands without touching your file system, which is a nice way to sort of dip your toes. And then a shout out to Software Carpentry, because I borrowed a lot of their images. They have a great, slightly more in depth of an extremely similar tutorial on how to do this. So if you want sort of a different version of the same material, they create great stuff. Go there for this or any of the other wonderful materials they have. And with that, I'm gonna stop sharing my screen and give it back to Agata and see if we have any questions.
Awesome, thank you very much, Kaylee. Thank you, everyone. I don't see any questions. What I will do really quickly is launch a poll. So we could just collect your feedback on the session. Oh, I apologize. There's and certainly if you have any questions, please do let us know.
Yeah, as soon as maybe while we're getting the poll up, if anybody who's remaining, if you have any questions about anything I said, or now if you have any maybe more specific questions, we can about Git or your workflow or anything like that, I'd be happy to stick around and chat. You can do the poll, but then if you have questions, can they unmute themselves, Agata? I think so.
Everyone.
It looks like Tony just did, so I think we're good. So yeah, feel free to just feel free
unmute
to
and
ask. You don't have, yeah, unmute and ask.
Hello.
Hey.
I'm sorry, I was late, so I probably went not view the post because I really do not have another get the whole picture yet. Are you going to post the talk online or somewhere?
I'm sorry, your audio quality, I'm having a little trouble understanding. Did you want to host the code online? Is that your question?
Have you recorded the presentation so I can watch it later? Because I was late.
Yeah, you can send an email into research.computing@yale.edu and I can help you there. But if I understood the question, which was how do you host the code online? GitHub can do that for you if you just change your code to be in public. And I have to refresh my memory, and I shot a slide about this. There's ways that you can actually get a URL and a DOI for your code if you want to cite it in your papers, or make it so other people can cite it in papers. And so you can, and that will redirect people to your GitHub page. Hopefully that's helpful.
Are you going to post your presentation online or somewhere I can watch?
Yes, I will be following up with an email, and I'll share the link to this presentation and the materials.
Oh, okay.
So, yep, you'll be able to re-watch that.
Any other questions? Also, you don't want to ask them here, feel free to email and I'll be happy. We can also set up a Zoom, a one-on-one Zoom to chat about get into your workflow if you have any questions about your specific coding environment or problem.
Yep, I'll share all of our contact info in my follow-up email as well, and I encourage you to reach out if you have any specific questions. If I could ask everyone to answer the few questions we have in the poll, just so we know sort of your impressions of this workshop, I would really appreciate it. Thanks so much for attending.
There's no questions. I think I'm gonna, okay. Yuki, I don't know if I'm pronouncing your name right. Can you send Agata or just DM Agata or your email address, and that way she can send you the follow-up.
Yeah.
All right, thanks everybody for coming, and I'll make sure that the up-to-date version of the slides are on our website, so you guys can. I mean, if you go to the tiny URL that was at the front, that goes directly to the GitHub to go to the Google presentation, but I'll make sure that there's a PDF in there as well.
Okay.
Thanks
Awesome.
all.
Thank you, Kaylee. Thank you, everyone. Please fill out the poll. I'll give you a couple more minutes and we'll end our session.
Okay.
Thanks again. Have a nice afternoon.
Thank you.